Hello, welcome to part 1 of the advanced features video for the Lilly version of the Powerstaxx tolerance analysis program. This is the first of 2 videos going over some of the advanced features of Powerstaxx. In this video, we will review changing the CPK, changing the units used for dimensions, and the part interaction sheet. The first thing to know is that you can change the CPK value in 2 ways, and both ways are on the dimension sheet. The first way is as the default value for the entire tolerance analysis, and that is done in this cell here. As you can see, it is 1.33, which is the standard Lilly practice. Changing this cell will change the assumed CPK for all dimensions in the tolerance analysis. The second way to change the CPK is per individual dimension. That is done in the specified CPK/PPK column. Simply input the value that is required for the specific dimension. Notice that it turns yellow to indicate that it is different than the default, and this overrides the default. The next thing to see on this sheet is how we can change the dimension units used in the tolerance analysis. In the upper left corner, the user can specify the units that are used for input and output linear dimensions. Input dimensions are the dimensions that the user enters on the spreadsheet in these columns here. Output dimensions in these columns here are what Powerstaxx uses in stackups on the tolerance analysis sheet. Powerstaxx uses input and output dimensions so that the units can be changed. If we change the default units here, notice that the values of the output dimensions change over here. Another option is to change the entered units for an individual dimension. That is done in the entered units column. If this cell is changed to millimeters, the output value changes back to 1.008 because we previously changed the output units to also be millimeters. The options in this column include degrees and radians for when angular units are required. If an angular unit is selected, the output unit changes to radians and the cells change color to indicate an angular dimension is used. For this version of Powerstaxx, the output for angular dimensions is always in radians. The final topic for this video is the part interaction sheet. The completion of this sheet actually starts on the dimension sheet. To be able to create a part interaction, it is necessary to fill in a part name on the dimension sheet. When entering parts and dimensions, it is important not to skip any sections. For example, you enter a part in section 4, but not in section 3. If that is done, the part interactions will not be properly created. Let's enter a part into section 3. After the part names are entered, we move to the part interaction sheet. Notice that the part names entered on the dimension sheet are already populated on the table. The next step is to define which pairs of parts create a part interaction. Where 2 parts combine to create an interaction, enter yes. Notice that when a yes is entered, a flag pops up to update part interactions. That is required because the final creation of the part interactions requires executing a macro. Where 2 parts do not create a part interaction, enter no. After entering yeses and nos, click the button to execute a macro that creates a list of part interactions. You will see that list in a moment. After running the macro, the reminder flag goes away. To use the just created list, go to the tolerance analysis page. Click in the green cell that says Choose Part Interaction. There in the drop-down menu are all the part interactions that apply to this assembly as defined on the part interaction sheet. Simply choose the one that applies to that stackup. Returning back to the part interaction sheet, there are a couple of points to make. First, it is important to make a habit of clicking the macro button after any changes, even with the reminder flag. The main reason is that if one yes is added and one is removed, the flag goes away, but the list of part interactions will be out of date. It is also necessary to avoid putting a yes in a square where there are no parts defined. That too causes errors in the macro execution. If there are extra yeses, a flag pops up as a reminder. Finally, as mentioned earlier, do not skip sections when entering parts in the dimensions. Let's enter a part name improperly on the Dimensions tab so you can see the effect. We'll enter button in part 6. The result is error is shown where the part name would be, and a flag on the right side reminding the user not to skip parts. That concludes part 1 of the advanced features video of Lilly's custom version of the Powerstaxx tolerance analysis spreadsheet. Please watch part 2 of the advanced features and the other videos to learn more. Thank you for your time. The next thing to see on this sheet is how we can change the dimension units used in the tolerance analysis. In the upper left corner, the user can specify the units that are used for input and output linear dimensions. Input dimensions are the dimensions that the user enters on the spreadsheet in these columns here. Output dimensions, in these columns here, are what Powerstaxx uses in stack-ups on the tolerance analysis sheet. Powerstaxx uses input and output dimensions so that the units can be changed. Notice the output dimensions change when the output units change.